Every second, the world keeps moving. Lights stay on, messages travel instantly, goods arrive, money moves, and systems respond without pause. None of this happens by chance. Behind everyday life, countless systems are working continuously, correcting errors and preventing failure. Most of the time, we don't see them. We only notice when something stops. Today, we are uncovering what keeps the world running every single second.
The modern world runs on a constant flow of energy. Electricity powers homes, hospitals, factories, communication networks, and transportation systems every second of the day. Power plants generate energy continuously, while grids balance supply and demand in real time. This balancing act is critical. Too much or too little electricity can damage equipment or cause outages. Most people experience energy only as a result. Lights turn on, devices charge, and machines operate. The complex systems behind this reliability remain invisible. Sensors, control rooms, and automated systems constantly monitor conditions to keep energy flowing without interruption. When energy systems fail, daily life stops almost immediately. Understanding energy flow reveals how fragile and essential this invisible system truly is.
Every second, billions of messages, calls, and data requests move across the planet. Communication systems operate continuously to connect people, businesses, and governments. Fiber optic cables, cellular towers, satellites, and data routing centers work together to transmit information at near light speed. These systems automatically choose the fastest and most reliable paths for data. Most users never see this complexity. Communication feels instant and effortless. However, behind every message is a chain of infrastructure coordinating timing, routing, and delivery. When communication systems fail, coordination breaks down rapidly. Emergency response, financial transactions, and social interaction all depend on constant connectivity. Communication infrastructure is one of the most critical systems keeping the modern world running every second. The availability of food, medicine, fuel, and consumer goods depends on supply chains operating every second. Raw materials are extracted, processed, transported, stored, and delivered through coordinated logistical systems. Software tracks inventory, predicts demand, and schedules transportation. Ships, trucks, trains, and planes move continuously to keep shelves stocked. Most people see only the final step, products ready to buy. The scale of coordination behind this is enormous. Delays or disruptions can cause shortages within days. Because supply chains are global, small issues can ripple outward quickly. These systems run constantly, adjusting routes and schedules in real time to keep the world supplied without pause. Financial systems process transactions continuously across the world. Every second, payments are authorized, accounts updated, trades executed, and balances adjusted. Banks, payment networks, clearing systems, and regulatory frameworks coordinate these actions automatically. When someone buys coffee with a card, multiple systems verify identity, availability, and security in milliseconds. Most users experience finance as simple and immediate. The complexity behind it remains hidden. Financial systems rely on trust, automation, and constant monitoring to prevent errors and fraud. If these systems stop, commerce halts almost instantly. Salaries, transportation, healthcare, and supply chains all depend on uninterrupted financial processing happening every second. Behind almost every modern system are automated control and monitoring networks. Sensors measure temperature, pressure, speed, usage, and demand in real time. Software responds instantly, adjusting systems without human intervention. Traffic lights adapt to congestion. Power grids adjust output. Factories regulate production. These systems reduce the need for constant human oversight and allow operations to scale safely. Most adjustments happen silently, without notice. When automation fails, humans often struggle to react quickly enough. This is why control systems are designed with redundancy and constant monitoring. Automated systems keep the world stable by making thousands of small corrections every second, preventing minor issues from becoming major failures. The modern world depends on precise time synchronization. Every second, computers, financial markets, communication networks, and transportation systems rely on accurate time signals. Digital systems must agree on exact timing to function correctly. Stock trades, bank transfers, GPS navigation, and data routing all depend on synchronized clocks. Even small timing errors can cause failures or security risks. Atomic clocks, time servers, and synchronization protocols operate continuously to keep systems aligned. Most people never think about time beyond clocks on their phones, yet behind those displays are global systems correcting and coordinating time constantly. Without precise synchronization, systems would drift apart, causing errors, delays, and breakdowns. Time is not just measured in the modern world, it is actively managed every second to keep complex systems functioning together. Environmental control systems quietly regulate the conditions that make modern life possible. Heating, ventilation, air conditioning, and climate control systems operate continuously in homes, hospitals, offices, factories, and data centers. These systems maintain temperature, humidity, and air quality within safe limits. In sensitive environments, even small changes can cause serious damage. Hospitals rely on controlled airflow. Data centers depend on cooling to prevent overheating. Industrial facilities require stable conditions for production. Sensors constantly monitor environmental data, while automated controls make adjustments every second. Most people notice these systems only when comfort changes. Yet without constant environmental regulation, many modern systems would fail quickly. Stability is maintained not by chance, but by infrastructure working continuously in the background. Even highly automated systems still depend on human oversight. Control room operators monitor dashboards, alerts, and performance indicators around the clock. Engineers analyze data, respond to anomalies, and intervene when automation reaches its limits. While machines handle routine adjustments, humans manage unexpected situations. Power grids, transportation networks, communication systems, and financial platforms all rely on trained professionals working in shifts. Their presence ensures safety, reliability, and accountability. Most users never see these people because systems are designed to run smoothly without attention. When failures occur, human expertise becomes critical. Understanding this reveals that the modern world is not fully automated. It is a partnership between machines that operate continuously and people who supervise, correct, and guide them every second. To keep the world running every second, systems are built with redundancy. Backup power supplies, duplicate servers, alternative communication routes, and failover systems stand ready to activate instantly. Redundancy prevents single points of failure from causing total collapse. Data centers maintain multiple power sources. Hospitals rely on generators. Communication networks reroute traffic automatically. These backups are rarely noticed because they are designed to remain idle until needed. When redundancy works, users experience no disruption. When it is missing, failures spread rapidly. Designing and maintaining backup systems is expensive and complex, but essential. Redundancy ensures continuity in a world that depends on constant operation. It is one of the most critical, yet least visible forces keeping modern systems alive every second. The systems that keep the world running are not static. They adapt continuously. Demand changes, technology evolves, and risks shift over time. Algorithms update parameters. Engineers revise procedures. Infrastructure is upgraded while still in operation. This constant adaptation allows systems to survive stress and scale with growing populations. Without adaptation, systems would fail under new conditions. Most of these changes happen quietly, without public awareness. Users experience continuity while systems evolve underneath. This ability to adapt every second is what separates stable systems from collapsing ones. The modern world runs not just because systems exist, but because they are constantly adjusted, improved, and corrected in real time to meet changing realities. The world runs because systems never stop working. Energy flows, data moves, and decisions are made every second. These systems are invisible, but their impact is constant. Understanding them changes how we see everyday life. The question is not whether these systems exist, but how well they are designed, maintained, and protected.